everyone, welcome to our video lesson on arithmetic sequences. Go ahead and grab your notebook and something to write with and your calculator to have handy. And we're going to dive into what an arithmetic sequence is, and then I'm going to show you guys a specific type of formula that we can use to help us predict terms within the sequence that we can't see yet. All right, so you'll remember from our last lesson that we talked about sequences as an ordered list of terms, and in our case, it's going to be numbers. And today we're going to talk about one specific type of sequence, which is called an arithmetic sequence. Okay, this is not arithmetic, even though it's spelled the same way. It's pronounced arithmetic. All right, so we're going to dive right into it. And the first thing that I have is two vocabulary terms that I'm going to use a lot throughout this video. Now, you guys can pause the video here, copy it down, or you can listen to me explain them as you write it down, just like you would in class. All right, an arithmetic sequence is an ordered list of elements because it is a sequence, but specifically, this is an ordered list where the difference between one term and the next always stays constant. So if I take a look at each term within my sequence, as I move from one number to the next number to the next number to the next number, not only am I going to find a pattern, but that specific pattern is going to be adding or subtracting. There's going to be a difference that stays the same every single time. We call that number the common difference. I mean, that should logically make sense. It's the same for every single space, so it has that in common. It's the common difference. But the important thing to note within this vocabulary is that it's always the number that's being added from one term to the next. So I know I said an arithmetic sequence can have a pattern of addition or subtraction, but when we go to actually labeling the common difference, which you guys are going to have to do in this video, make sure you ask yourself, what's being added to get to the next term in my sequence? And in today's video and in future lessons, I'm always going to refer to the common difference with the letter D. So if this comes up, just know that it stands for the common difference. So let's get into some examples right away. Here are four sequences. Your question right now is to decide, are these arithmetic sequences? If they are, then find that common difference that is the same throughout the entire sequence. So I'll go through the first example with you, and then I want you to try the next three on your own. Okay, if I look at the numbers 3, 5, 7, 9, keeping in the back of my head that I'm looking for a pattern of addition or subtraction, I'll notice that in order to get from 3 to 5, I would add 2. And the same thing happens adding 2 to get from 5 to 7 and 7 to 9. So yes, this is arithmetic, and the common difference D is the number 2 that I'm adding every single time. Okay, now that example was relatively simple because those numbers are small and pretty close together. I could figure out that 3 to 5 is plus 2. But if those numbers were bigger and a little more spaced out, I could find this common difference by simply going from one term and subtracting the one before it. 9 minus 7 is 2, 7 minus 5 is 2, and 5 minus 3 is 2. Okay, and that's where this term actually gets its meaning common difference, because you actually find it by using subtraction, and you guys know difference is the answer to a subtraction problem. All right, so pause the video, see if you can answer the next three questions. First of all, is it an arithmetic sequence? And if it is, what's that common difference? All right, so how'd you guys do? Okay, number 2 is an arithmetic sequence because you're adding 7 every single time. So that common difference is the positive 7. In number 3, it's arithmetic because you're subtracting 5 every single time. That difference stays constant. But when it comes to, be careful here, remember we said the common difference is the number that's being added every single time. So if you notice a pattern of subtraction, just think of it like when you first learned about negative numbers, subtracting is the same as adding a negative. So if I see subtract 5, subtract 5, subtract 5, then I know my common difference is the negative 5 that I'm adding every time. Okay. Number 4 is not an arithmetic sequence. You are adding 1 when you go from 1 to 2. You're adding 2 when you go from 2 to 4. And you're adding 3 when you go from 4 to 7. So yes, it does have a pattern, and I probably could predict what's about to come next. But in terms of classifying it as an arithmetic sequence, this one does not have a constant common difference. That number would have to be the exact same every single time. Okay, so if we recognize an arithmetic sequence, we can use something called an explicit formula, and it's the same outline for all arithmetic sequences. We just have to fill in some very specific information to the sequence we're talking about. But then this formula is actually going to allow us to find any term in the sequence. See these dot, dot, dots? That means that these patterns go on forever and ever and ever. And I could probably predict what comes after 9 and what comes after 11 and what comes after 13. Those would be the next few numbers. But what if I wanted to figure out what's going to happen in the 100th space or in the 50th space? What number is going to be way far down the line, and I honestly don't feel like adding to every single time until I get there. Okay. Well, arithmetic sequences relate to linear functions. So we're going to develop, well, we're not going to develop, it was developed for us, but we're going to use a linear equation in order to predict any term that we want. And like I said, they've already come up with this formula. We just have to have it memorized. Okay. So here's the explicit formula. Go ahead and copy it down and let me explain what each piece means. Okay. Remember, a sub n is a variable. It's representing any term in the sequence. So we don't know what term we're going to be looking for yet, which is why we use the placeholder a sub n. But normally what they'll do is they'll say, okay, find the 8th term, and this would show up as a sub 8. Or find the 21st term, and this would show up as a sub 21. So that n there allows us to use whatever term we want, whichever spot we want in the sequence. We leave it as a variable until it's known. Okay, this one is already filled in, and you guys know from our last lesson that this is the first term. Oops, spell first, right? In the sequence, so finding a sub 1 and then the number that's in that first spot would fill in that space. D, we just learned, is the common difference. So what are you adding every single time? Okay. And then you'll notice that this n that we saw in the beginning is showing up again, but now it's like on the same level as every other letter that we have in our equation. It's not a subscript. Subscript is down in the bottom right hand corner. When it's big and level like this, it's actually going to represent the order or the spot that you're looking for. Okay, so I'm going to call it the, what's a good way to say? All right, so let's say I was trying to look for a term like the 5th term in the sequence. This would be a sub 5, and remember that's just a notation. There's no math that goes into that. But I would use that 5 because I'm trying to find the 5th term in my actual equation itself. All right, and I'll show you guys exactly how to use this equation and how to plug things in, but I just want to make sure you understand where each term comes from. All right, so I had to go to the next page, so I just rewrote that formula up here at the top of my page. Same exact formula from the last page, so you don't have to write it down again if you're on the same page in your notes. But now let's do some examples where we're going to actually come up with the formula to represent the entire sequence or any term within the sequence. Okay, here's your first example, 2, 8, 14, and 20. Okay, so 2 important things to notice. Number 1, 2 is my first term. There's my a sub 1. Okay, and it is an arithmetic sequence because going from 2 to 8 is adding 6, 8 to 14 is adding 6, and 14 to 20 is adding 6. So there is my common difference. Okay, so when we write our formula to represent the entire sequence and to represent any number within the sequence, we're going to leave that n as a variable. We're going to wait until someone clarifies which term you're actually looking for. So a sub n equals, and then I'm going to fill in the values for this specific sequence. A sub 1 was a 2, so it would be 2 plus your common difference, which is a positive 6. So I'm going to put the 6 and then in parentheses n minus 1. Remember, we don't know what term we're looking for yet, so when this is an n, that's an n as well. Okay, the only thing that you may notice as we go through these examples is that a lot of times they will simplify this formula down, and they'll actually do the distributing. This would be 6 times n and 6 times -1. So this would be a sub n equals 2 plus 6n minus 6. And then they'll combine like terms. A sub n 2 plus 6n minus 6, and then they'll combine like terms with the 2 and the -6, so a sub n equals 6n minus 4, and that might be your final answer. Okay, so try it out, pause the video. I'm only going to ask you to do 2 and 3 because they're very similar to 1, and then we'll come back and see how you did. All right, so how'd you guys do? In our second sequence, we start with a 1 and we're adding 0.5 every time. So as I fill in those two spots and simplify, I get a sub n equals 0.5n plus 0.5. My third sequence is starting at a 5 and then subtracting 3 every single time. So I plug the 5 in for the a sub 1 spot and a -3 in for the common difference. Now, you guys know I hate this double sign here. I think it looks sloppy. So I would normally write it as just -3 because adding a negative is subtracting. But I wanted to put it this way just so that you recognize that I'm literally plugging in for D, whatever number you're adding to move to the next term. Okay? Be careful to distribute, make sure you distribute carefully. -3 times n would be -3n, and then -3 times -1 would be +3, combined with the 5 is an 8. Okay, then I wanted to show you guys some questions that they might throw at you that are similar but with a slight curveball to them. For example, number 4 says, in a sequence a sub 4, so the fourth term is 19, and a sub 7 is 31, so the seventh term is 31. Write a formula for the nth term of the sequence. So this wording comes up a lot. If they want a formula for the nth term of the sequence, they're just looking for one of these general formulas that would help them find any number they're looking for. Okay, so first thing here is that I have a sub 4 as 19 and a sub 7 as 31. Now, neither one of those are the two pieces of information that I need for my actual formula, okay, but they can help me find the common difference. The visual that I like to set up is if this was like 2, 3, 4. If I was writing out my sequence, the fourth spot, 1, 2, 3, 4, would be 19, 5, 6, 7th spot would be 31, and I need to figure out what this first number is, and I need to figure out what the difference is in between terms. Okay, so algebraically, we start by finding the common difference. You'll notice here that I have to take 1, 2, 3 jumps to get from 19 to 31, so I'm curious how much is each one of these jumps if it's the same every single time. So algebraically, we would take the 31 minus the 19 to figure out how far, what the general difference is. But then I want to divide it by 7 minus 4, spot 7 minus spot 4. This is going to give me the 3 jumps that I was talking about here, and then this is going to give me the total distance that I have to divide by 3 jumps in order to get each one. So 31 minus 19 is 12, 7 minus 4 is 3, and 12 divided by 3 is 4. So that means that each term would be, I'm going to do it in purple, plus 4, plus 4, plus 4. Okay. Now, you can use that to your advantage, and you can actually go subtract 4, subtract 4, subtract 4 to get back. But obviously, there's an algebraic way to find almost anything. So if I use my formula a sub n and fill in what I do know so far, a sub n equals a sub 1, I don't know yet, plus 4 times n minus 1. Okay, I can actually use one of these two terms and plug them in so that I can figure out the one thing I don't know, which is a sub 1. So let's say we use this statement, a sub 4 is 19. Okay, so if a sub 4 is 19, then I would be plugging a 4 in for the n spot. But a sub 4 is 19, so that means 19 equals a sub 1 plus 4 times 3, and if 19 equals a sub 1 plus 12, subtract that 12 over, a sub 1 equals 7. Okay, little algebraic way to find it, but again, you could just maneuver backwards and subtract 4. Or you can say, okay, 1, 2, 3 spots, that means I have to subtract 12. Hey, that's what happened here. And that's how I get my a sub 1. So now I know my common difference is 4, my a sub 1 is 7. So let's go ahead and write the general formula. Okay, that would be a sub n equals 7 plus 4 times n minus 1, using those two pieces of information back up here in my formula. And if we simplify that, distributing the 4, we get 4n minus 4. Combining like terms, a sub n equals 4n plus 3. Woo, a lot of work for that one. Okay, but knowing how to do this helps us sometimes in more logical or real life situations. For example, here, first row of the auditorium has 55 seats, second row has 58, the third row has 61. How many seats will be in the 25th row? Okay, well, what I'm noticing is that we start with 55 seats. In order to get to 58, I add 3, and in order to get to 61, I add 3 again. So I have an arithmetic sequence representing the number of seats in each row. So let's use the formula up at the top. A sub n equals a sub 1, which is 55, plus the common difference, which is 3 seats added each time, times n minus 1. And now they want us to find the 25th row, so it's going to be a sub 25 equals 55 plus 3 times 25 minus 1. And you'll notice that I didn't even bother simplifying this and distributing, because if my job is to find the 25th row and I know I'm going to plug in the number 25, then I'm going to leave out that simplifying and just let my calculator calculate this out. Oops. 3 times 25 minus 1. That way we don't risk making any mathematical errors with simplifying. Okay, so this tells me that a sub 25 is 127, so there will be 127 seats in the 25th row of the auditorium. Okay, now this leads us right into the last thing I want to cover for today's lesson, which is actually using this, what we call explicit formula. Okay, so the very simple way that we would use this is to find a term in the sequence that we don't know. And what I did here is I gave you 3 formulas for 3 different sequences, and you don't even get the list to go by. You don't even get the first few terms to look at. Okay, I want you to find the 4th term of this sequence represented by this formula. Well, it's as easy as replacing the 4 for the n in my formula. So if I want to find a sub 4, I'm going to do 15 times 4 plus 8. 15 times 4 plus 8, easy as typing on your calculator. A sub 4 equals 68. Okay, try the next 2, see if you get them right. Pause the video. All right, and those are the answers for questions 2 and 3. Again, just take the subscript number, plug it in for the n in your formula, and let your calculator do the tough stuff. All right, this is it on arithmetic sequences. You'll have a practice with this stuff tomorrow, so make sure if you don't understand the notes, send me your questions, and I will see you guys at some point tomorrow. Have a great day.